We are now good to begin with the session. So, a very warm welcome to all the students and parents. So, for you three, Jashmita, Joyal, and Raghavendra, I see that your parents are not sitting beside you, but then for the others whom I cannot see, maybe if there are any parents sitting around, a very warm welcome to all of you as well. So, today we are here for a demo and interaction program for grade 9 mathematics. And as I had asked you earlier also, so you would be going in grade 9th in the academic year 22-23. So kids, like a few of you would were not knowing about Olympiad success. So Olympiad success is India's largest preparation platform for Olympiad examinations. And, in the last year, basically in the academic year 2021, we had almost 40 plus international rank ones, which is a great thing actually. So there were students who had obtained international rank ones across various Olympiads conducted across the country. Okay, so we understand that apart from the preparation from Olympiad success platform, there is a lot of effort put in by the student side, the parent side, and the mentor side as well. So it's an equal combination of all these things which makes a student successful. And at Olympiad success classes, we make sure that your foundation is cleared, because ninth, as you all know, it's the foundation class. So soon you would be going in grade 10th and your competitive examinations would be coming in, right? So we here make sure that your foundation is really strong and you can appear for these competitive examinations. So kids, we have been successfully running these live classes from the past 2 years now, and this is our third year. So this third year, we have introduced three more live classes, which are for your CBSE. Okay, so we have introduced the CBSE preparation classes, and those are long classes, like basically long duration, as in 10 months long classes. And apart from that, we have introduced classes for international mathematics Olympiads preparation also. So students, if you are aware of the examinations like SASMO, CMO, TMO, HKIMO, and various other Olympiad examinations conducted internationally. So we have started preparation for that as well. If you're interested for that, you can certainly ping us on our WhatsApp number and we can let you know the further details. And finally, we are starting with the JEE mains classes. So these would be specifically for JEE mains and not for advanced. So we have come up with this specialized course because right now, as you can see, no other organization, they focus on only the mains preparation. Okay, so wherever, in whichever institute you go, there is a combination of both both the classes, basically the mains and the advanced. Okay, so both these are introduced, but then we would focus on mains, and our aim or our motto would be that all the students are enrolled, like they get admission into various NITs and colleges equivalent to NITs. Right. So now, kids, the about this session, like particularly this demo session, your flow would be, first of all, there would be an introduction by Tariq sir. So I would say, like, he has been a wonderful mentor and he has been associated with Olympiad Success family for quite many years now. And there is a special privilege which students get upon enrolling to his class, which is you get a specific WhatsApp group with him. So apart from your regular classes, the live classes which you have with Tariq sir, you can certainly, ask questions on the WhatsApp group, and he would be happy to help you, because he believes in, solving the queries of the students then and there. So he has specifically created groups for these classes, and he would be happy to help. So after the introduction of Tariq sir, we would be having a short presentation by Rajan sir, wherein he would be explaining you about the details of this course. Okay, so all the things would be covered in that presentation. After that, we would be having a short question and answer round. So if you have any doubts, queries, you can write it down in the chat section and we will be happy to answer all your doubts and queries. Post the doubt session, we would be starting with the demo session for which you all are here. Okay, kids. So this would be a 1 hour 15 minutes class. So we had started at 7 p.m. and it would be ending at 8:15. I'm so sorry. It started at 7 p.m. right, and it would be ending at 8:15 p.m. So it's 1 hour 15 minutes class. So over to you, Tariq sir.
Thanks, Arti ma'am. Hi guys, I'm able to see Raghavendra, Jasmita. It's good to see you after a break. And Sanvi is also present there, but she has not kept the video on. Sanvi, if possible, turn on the video. So, hi everyone, myself Tariq Ahmed, and I have been in this profession for last 20 years. I have been teaching mathematics since 2002, and I start taking classes from standard 8 and take classes up to graduation level. So some of the students I'm able to see here, they are my, they have already taken the classes. So the goal for the classes is that we always start from the basics, and because basics are important, foundations are necessary for multi-story building. So we always focus on the basics, and then gradually we increase the content of the content and the material, and then we take it to the advanced level. We in ninth standard we normally explain a lot of things from 10th class as well as 11th also, which are important and which are asked in the Olympiad examination. So, and as Arti ma'am said, and some of you have already experienced in the past, that there is exclusively a WhatsApp group there with us, and that privilege is with me, and I'm thankful to our director Nitin sir for this. So you can interact with me irrespective of the class. Whenever you have any doubt, you can ask me, and I would prefer to explain all your doubts. So this is one extra thing which you are going to get. So if you are committed and if you are really interested in learning a lot of new things, then you can get a lot of help from us. And we know that our final aim is to get a good rank in some good Olympiad examination. So if you go through all the content and after a rigorous training, we are very confident that if you are listening us, you are helping us, you are listening. In fact, most of the time what happens that students do not listen. Sometimes we say that okay, just go and solve these questions. So if you are doing that, we are very much sure that you are going to get a result of your desire. So that's from my side, a brief introduction. In quite some time I will give the demo. So that's now from my side, Arpana.
Yeah, thank you so much, Tariq sir. It's indeed pleasure to have you on the platform. And as Tariq sir again mentioned, and I too had mentioned, so it's a equal effort by all the sides. So your mentor would be trying his level best, but then you too have to put in your effort, okay, and to get good marks and to lay your foundation really solid. Okay. So now over to Rajan sir for taking up a short presentation about this course, and then we can have the question and answer round.
Yeah, sure. Thank you, ma'am. Students, my screen is visible.
Yes,
Yeah.
now it is.
Okay, okay. Yeah. So firstly, welcome to the demo, class 9th Olympiad. Okay. Firstly, let me tell you about us, about Olympiad Success. So Olympiad Success is India's largest online platform for Olympiad exams. We have Olympiad live classes. So it is again India's first exclusive live classes for Olympiad preparation. We have School Plus program. In School Plus program, we have 8 courses: mathematics, English, science, logical reasoning, communication, in communication, spoken and written both, Vedic maths and coding. Now about this batch. So what we offer online CBSE classes for grade 6 12, one-on-one preparation for international mathematics Olympiad like SESMO, that is Singapore and Asian Math Olympiad, CMO Southeast Asian Mathematics Olympiad, Hong Kong International Mathematics Olympiad, Thailand International Mathematics Olympiad, Math Count, US Mathematics Olympiad, Math Kangaroo, PRMO, and we also give JEE mains preparation classes. Now meet our rank holders for 2021. For 21-22, we are compiling the results and we will release soon. So in various Olympiad exams, these are rank holder of Olympiad Success. we have students secure this rank. So we have 40 plus international rank 1, 70 plus top 5 international rank, 120 plus top 10 international rank. Now about this course, there will be 20 students in a group and the class will conduct on Zoom platform. 3 sessions per week. The days are Monday, Wednesday, and Friday. Timing will be 8 p.m. to 9:15 p.m. So it will be a class of 75 minutes duration. In between, there is a 5-minute break. Okay. So the session include a mix of theory, practice question, doubt session, and also discussion on previous year paper. Student will also get reading material and practice question, which will be available on the dashboard of Olympiad Success. And student will get a free access to Olympiad Success platform for practice mock test of mathematics or logical reasoning. Okay. Now about the fees. Fees for this course is 12,720 and there will be 60 sessions. Okay. The link I will share in the chat box. Okay. So the fee include online classes, daily reading notes and exercise, practice of previous year paper, and access to Olympiad Success maths and logical reasoning mock test and worksheet. Okay. And students, if you enroll today, you will get free CREST Mathematics Olympiad, that is CMO exam. Now, what you need to join this course, a laptop with good internet speed, and if possible, a headphone. Okay. So students, preparation for Olympiad is quite tougher than your school curriculum because there is some topics from your upper grade also. Okay. So students, we always advise to spend some more hours to cope up with the curriculum, and also parent support will be needed to check answers and retrieve the concepts. Live classes for this batch will start from 25th March. So currently we have students from 3,800 schools and we are actually catering in 35 plus countries. So this is about this course. Now students, if you have any doubt or any question, you can ask in the chat box.
Thank you so much, Rajan sir, for this detailed presentation. So students, do we have any doubts coming in? No? All clear?
Okay, so can anyone tell me like what are the days on which you're having a class?
Monday,
Monday,
Wednesday.
Wednesday, and Friday. Vivek answer. Okay, okay. And what is the timing?
Meanwhile, you write your time answer. I see that Mananki, you have raised your hand. Raised your hand. If you have any doubt, please write it down in the chat section. Okay, 8 to 9:15. All right. Any further doubts? All clear session about this course? So what all you'd be getting, you are clear about that? Okay. All right, then it's wonderful. So maybe then we can start with the session. Rajan sir, do you have? Okay, I've got one question from Riti. What is the fee structure? So can anyone let me know, like, what is the fees? 12,720 rupees. Absolutely. It is in INR, Indian National Rupees, and it is payable at once. Like before joining the classes, you need to pay, then only you can start with the classes. Okay, thank you so much. Thank you so much, kids. Any further question? Yes, Minani, thank you so much. It is 12720.
So I think Aarti ma'am, we can start with the session.
Okay, should we
Everything
start
is
with the
clear to them.
session, students? Yes? Yes. So show me some excitement, kids. Right? Should we start? Yes, absolutely. We will start. So, kids, before starting, can anyone let me know like what Tariq sir will be teaching us today? And I've told us, so maybe I'll also learn few tricks from Tariq sir today. Basics, but then basics about what? Which topic? Of course, Sahasra, but then it's mathematics. Of course, this is the subject. You need to tell me the topic. Number systems, BODMAS, Okay, so Tariq sir, we are getting in a few options, but I too don't know what are we going to, learn today. So it would be better if you can come and unveil what uh, we would be learning today. Linear equations, Jasmita is saying. So over to you, Tariq sir.
Okay, thank you, ma'am. So we got one correct guesses. One student just said that I'm going to take number system. So that's correct answer. Hard luck, Jasmita. Your guess was not correct. Okay. So in number system, we have to learn about numbers and one particular number that is in the syllabus of 9th class, and that is irrational number. I'm very much sure that some of my students have already idea about this number. So let's see. Raghavendra, Jasmita, Sanvi, Saraswati is also present. Just say Y for yes, N for no, if you have idea about that. Yes, yes, good. Okay, so I'm going to explain this irrational numbers. Now, before coming to irrational numbers, in fact, in 8th standard, in our syllabus, there was a rational number. So let me start from rational number. Rational numbers. Its definition is the number which can be expressed in the form P by Q, where Q not equal to 0 is called a rational number. Okay. So like 5. Okay. Is 5 a rational number? Yes or no? Write in the chat box. Yeah, correct. Because we can write it's in the form of P by Q, 5 by what? Okay. What about -2? Whether this is a rational number? Yes, correct. It is also a rational number. What about 2 by 3? Is it a rational number? Yes, correct. Good. Okay. What about 1.3? Is it a rational number? Yes. We can write this 13 by 10 in the form of P by Q. So this is a rational number. Now here comes to the condition. We cannot put 0 at the place of denominator. Means Q cannot be 0. 5 by 0. If we are putting 0 here, it is not permissible. We cannot do that. Why? Anybody has idea why? What is the reason? Yeah. So write in short, why? Undefined. Correct, correct, correct. So 5 by 0, this is known as undefined, right? And in another term, you can say infinity. So when a number is divided by 0, that is known as infinity. And since the value of infinity is not defined, that's why it is called undefined. Okay. So this was rational numbers. Now you may have also learned that rational numbers can be, okay, before that, tell me, rational numbers are denoted by which letter? I hope some of the students may have idea. No. Yeah. Saraswat is correct. Good, Saraswat. Q. Rational numbers are denoted by the capital letter Q. Capital letters is denoted by Q. Okay. Now, rational numbers can be either terminating or non-terminating. Rational numbers, these numbers can be terminating or non-terminating. Okay. So both type of numbers, terminating as well as non-terminating, they are the examples of rational numbers. Which number would be terminating? Here is the rule. If P by Q and Q contains 2 as a factor or 5 as a factor or 2 and 5 both as a factor, if denominator contain either 2 as a prime factor or 5 as a prime factor or both 2 as well as 5 both are present in the prime factors of denominator, then that rational number would always be terminating. Always be terminating. Now see, example 7 by 2. Here I have kept 2 at the denominator. Its value would be 3.5. Now see, it is terminating decimal. It comes to an end. After 5, there is no digit, it is 0. Another example, 7 by 5. Its value is again 1.4. It terminates after 1 digit after decimal. Now, 7 by 2 into 5, 10. Now I am putting both. So 7 by 10, this is 0.7. It also terminates. That's why I said whenever denominator contains either 2 as a prime factor, it would be terminating, or 5, it would be again terminating, or 2 and 5 both, it would be again terminating. Good. But if any other number beside 2 and 5 is present in the denominator, then that rational number would be non-terminating. I'm again repeating. If any other number beside 2 and 5 is present at the denominator place, then that rational number would be a non-terminating decimal. For example, see 7 by 3. See clearly here neither 2 nor 5 is present, only 3 is present. So its value is, okay, I'm coming to that point, just wait. 7 by 3, it is 2.33. Okay, and it will go on endlessly. So we can write it in bar, 2.3 bar. This is also a rational number, but it is of non-terminating. 7 by 11. Again, it is other than 2 and 5. So when we will divide 0.643, then 0.63 means 63, 0.63 bar. We will get that. So this is non-terminating decimal. So if denominator contains any other number beside 2 and 5, then that rational number would be non-terminating decimal. So what we learn? We learn that rational numbers are either terminating or non-terminating. Both can be present. Both can be the example of rational numbers. For terminating decimal, denominator must contain either 2 or 5 or 2 and 5 both at the denominator. But if any other number beside 2 and 5 is present in the denominator, then that rational number would be example of non-terminating. Okay. Someone asked, what about 6 by 3? So you are able to see 3, neither 2 nor 5. But see, the number which I have written here, 7 by 3, okay, or 7 by 11, this is in the standard form, while this number is not in the standard form. So if number is not written in the standard form, our first task is to bring that number in the standard form, in the lowest term. See, this is in the lowest term. 3 is not going to cancel 7. 7 and 3 both are prime numbers. 7 and 11 both are prime numbers. So it is in the standard form. But here 3 is a factor of 6. So this fraction is not in the standard form. So right now we cannot judge. Right now we cannot judge whether this is terminating or non-terminating. To apply the rule which I just explained, you have to bring the number first in the lowest term. So cancel this 3 2 ja. Now this is 2 by 1. Now you know this is a terminating decimal. Suppose 33 by 11. Now the question is asking, tell whether this is a terminating decimal or non-terminating decimal. So by just watching 11, you cannot judge. You have to bring this in a standard form if the number is not in the standard form. Right now you know that 11 is a factor of 33. So cancel this, you will get 3. Now you are able to see that this is a terminating decimal. I hope the question who asked, the doubt is clear. So what we learn? We learn that rational numbers are of the form P by Q, and P by Q form, Q should not be equal to 0. Rational numbers can either be terminating or can be non-terminating. For terminating decimal, denominator must contain 2, 5 or 2 and 5. If any other number beside 2 and 5, then that would be a non-terminating decimal. Okay. Now coming to our main topic, irrational numbers. Irrational numbers. Anybody has idea what are irrational numbers? Just write if you have idea. See, factor of 2 and 5 both. I gave the example 7 by 10. 10. 10 is the factor of 2 and 5 both. So you can write 2 and 5 both. Again, it would be a terminating decimal. I explained that. Okay, so if you are answering, so I'm going to write the definition. Irrational numbers. Those numbers which are non-terminating and non-repeating. Those numbers are called, no, this is not the definition. This is the definition. This is the definition for irrational numbers. The numbers which can neither be terminating, which can neither be terminating nor repeating. That is the definition. Means any number which are non-terminating as well as non-repeating. These numbers are called irrational numbers. Okay. Now see, what is the meaning of terminating and non-terminating? 2.1. Now I'm asking, answer accordingly. Tell me, 2.1 is a terminating decimal or non-terminating decimal? It is terminating or non-terminating? Terminating. So since it is terminating, so it will not be an irrational number, because every irrational number must be non-terminating. Correct? So this is not example of irrational number. Okay. 7.3 bar. Now tell me whether this one, the second one, is a terminating number or non-terminating number. Yeah, this is non-terminating. Correct? Correct. So can we say that this is example of irrational number? No, yes. Some few are answering yes, no. See, to call a number irrational, there are two conditions. Failing in any one condition will rule out. Means to call a number irrational, The number must satisfy both the conditions. If that number is satisfying both the condition, then we can say that, okay, this is example of irrational number. So one of the condition is non-terminating. Yes, the first condition, it is fulfilling. We checked. First condition, it is fulfilling. But what about the second condition? Second condition says it must be non-repeating. Means number should not repeat itself. Here, when we write this in expanded form, we will write 7.3333 dash dash dash. See, although this is non-terminating, not going to end, but it is repeating itself. 3 is repeating again and again. So second condition, it is failing here. That's why again, this is not an example of irrational number. Good. So again, I'm repeating. Any number would be irrational number if that number is fulfilling both the conditions. Another example. 5.20202 dash dash dash. Tell me whether this is example of irrational number. No. Saraswati is also saying no. Raghavendra is saying no. All are incorrect. See, I said the number, two conditions are there. It should be non-terminating. Okay. That condition, it is fulfilling. Non-terminating, it is going endlessly. What about the second condition? This is saying non-repeating. See the difference. Here 3 is coming again and again. But see, if you take 2, then 1 0, then again 2, then 2 0. This is not same. Then 2, maybe 3 0. Or if you are taking two numbers 20, then here it is 200, not 20. So these are in fact not repeating itself. This is not repeating itself. That's why this is the example of irrational number. It is different from this. See carefully. Here 3 is repeating. But if I write like this, 7.3 and then write 1, then 2 3, then 1, then 3 and then 1. Now tell me whether this is irrational or rational. First, irrational, correct. Because it is non-terminating as well as non-repeating. See, 31, 33, 13, 33, so on. It is not repeating itself. That's why this is the example of irrational number. Clear? If anyone has any doubt, ask. I will explain again. Fine, Anusha? Good, Saraswat? Okay, good. Okay. So, we learn about irrational numbers. When we find the square root, yeah, Denominator is not 2 or 5. Oh, who is asking? Shweta. 6/3. Shweta, I explained that before judging, you have to bring the number in the standard form. Shweta, tell me whether this number is in the standard form or not. Shweta, answer first. No. So you have to bring this first in a standard form. Means 3 1 ja, 3 2 ja, 2 by 1. Now judge. Now try to find out whether this is terminating or non-terminating. Shweta, got it? Good. Another example. 50/7. First of all, find out whether this is in the standard form or not. Sweta, I'm asking to Sweta. This is in the standard form? Yes, Raswat, wait. I'm waiting for Sweta. It is in the standard form or not? No, Sweta, this is in the standard form. 7 is not a factor of 50. 7 is not a factor of 50. It is in the standard form. So now you have to judge. And it contains other number than 2 and 5. So this is non-terminating decimal. Non-terminating. Yeah, simplest form, that is known as a standard form. So you have to bring the number first of all in a standard form and then apply the rule. After bringing it to a standard form, if denominator contains either 2 or 5 or 2 and 5 both, it would be terminating. And if any other number present beside 2 and 5, then it would be non-terminating. Okay, now come to this irrational number. So irrational numbers are those numbers which are non-terminating as well as non-repeating numbers. We learn that. Now, when we find the square root of a number, like root 2, root 3, minus root 5, 7 root 3, all these numbers are the examples of irrational numbers. Got it? These are also the examples of irrational numbers. Now see, sum of two irrational numbers can be either rational or irrational. See, one property I have written here. If we are adding two irrational numbers, then what would be the result? This property says that result would be either rational or irrational. Now I am going to explain this by the example. Saraswati, we will get either rational or irrational. We can get rational as well as irrational also. It depends. What are the numbers? Let's see. One number is root 2. Tell me whether this is rational or irrational. This is rational or irrational? Irrational. Another number is minus root 2. This is again irrational. Now we have to add these two irrationals. What would be the result? What would be the result? Correct. We will get 0. And 0 is rational or irrational? 0 is rational. Correct. So, sum of two irrational, we are getting a rational. This is irrational, and this is rational. Correct? Now, another example. Root 2 and root 3. Both are irrational. And then we are going to add. What would be the result? It will remain same. It will remain same. And this is again irrational. That's why this is the property which is saying when we add two irrational, we may get a rational number, we may get irrational number. So this is one of the important properties. Sum of two irrational numbers can be either rational or irrational. See another example. 5 plus root 2. Tell me whether this is rational or irrational. 5 plus root. Correct. Irrational. See, sum of rational and irrational is in fact irrational. So some rational and irrational. Sum. So this is irrational. So this is irrational. Okay. 5 minus root 2. Tell me whether this is rational or irrational. This is again irrational. Correct? Irrational. Now we have to add. We have to add. When we will add, this root 2 will cancel this root 2. So 5 plus 5, we will get 10. And 10 is a rational number. So after addition of two irrational numbers, we are getting a rational number. Now see the same example. 5 plus root 2 and root 2 minus 5. This is irrational, this is irrational. Both are irrational. And when we will add these two numbers, minus 5 will cancel plus 5, root 2 plus root 2, we will get 2 root 2. This time we are getting irrational. That's why this property is saying sum of two irrational numbers can be either rational or irrational. Got it? Write in the chat box if you have any doubt, or if it is clear, write wise yes. Good. 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 Okay. Now another property. Product of two irrational numbers can be rational or irrational. This is again important property. Both the properties are very important. Earlier I explained for the addition. Now I'm going to explain for the product. If we are multiplying two irrational numbers, the property says we will get either a rational number or we will get an irrational number. Both can happen. Now see example. Root 2, this is an irrational number. Root 3 is another irrational number. Yes, Raswa, just wait. I'm coming. Root 2 and root 3, when we multiply, it would be root 6. See, irrational product, we are getting irrational. So it is true for irrational. Now see another example. Root 2 into root 2. Both are irrational. And root 2 into root 2 would be root 2 into root 2 would be, this would be 2. We have to keep in memory that root a into root a is always a. This should be there, encrypted in your memory. Root a into root a will always be a. Means root 2 into root 2, 2, root 3 into root 3, 3, root 5 into root 5, 5, root 7 into root 7, 7. In general, root a into root a, we will get a. So see, this time we are getting a rational number. Earlier we were getting irrational number. See another example. 3 plus root 2. Tell me, this is rational or irrational? This is rational or irrational? Irrational. Another number I am writing 3 minus root 2. This is rational or irrational? Again irrational. And we have to multiply product. We can use the identity a plus b into a minus b. What is the identity a plus b into a minus b equal to? Let's see who is going to tell me. A plus b into a minus b. Good. A square minus b square. So we can write 3a square minus root 2a square. So we will get 9. Root 2a square is 2. We will get 7. Now see, this is a rational number. This is a rational number. While these two are irrational numbers. And as a product, we are getting a rational number. So this is an important property, that product of two irrational numbers can be rational or can be irrational. It depends which two numbers we are multiplying. But product of rational and irrational is always irrational. Tell me whether this statement is true or false. Let's see who is going to answer this correctly. Okay, true, 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 more, true. Let's see. So far all the answers true. One. No. You have to say true. Okay, T for true. So everyone saying true. Raghavendra, what you want to say? True or false? True. Okay. Raghavendra also saying true. No, all are incorrect. This is not true. In fact, this is false. See, where it is failing. And this is important question. This is asked in the Olympiad paper because most of the students say this is true. See, root 2 into root 3. Yeah, root 6. Sorry, 2 into rational and irrational. 2 into root 3. Okay, so this is 2 root 3. Minus 5 into root 2. Minus 5 root 2. Everyone thinks, okay, we will always get error. But 0 is also a rational number. You have idea. And when we will multiply a number with 0, then what would be the outcome? Okay. So 0 into root 5, we will get 0. Here we are not getting irrational. Here we are getting rational. So this property fails here only. Leaving this example, this is true. But due to this example, this is in fact false. This is one of the important questions asked in the Olympiad paper. I hope this doubt is also clear. Yes or no? Okay, good. Now see, one term I am going to write down here, rationalization. Rationalization. What is the meaning of rationalization? Rationalization means to bring a rational number at the place of irrational number. The process is called rationalization. So, rationalization is a process to bring rational numbers at the place of irrational numbers. And that process is known as rationalization. Now see, one keyword I am going to tell you, a plus b, and there is another number a minus b. So we call it a plus b is called conjugate of a minus b, or a minus b is called conjugate of a plus b. This is the technical word used. So 2 plus root 3, what would be its conjugate? Who is going to tell me? The conjugate of 2 plus root 3. It would be 2 minus root 3. Good. Just you have to change the sign. Okay. 5 minus root 7. What would be the conjugate of 5 minus root 7? It would be 5 plus root 7. Correct. You just need to change the sign. And these two are called conjugates of each other. Okay. So to rationalize a number, the rule is to rationalize a number, we multiply and divide with the conjugate of that number. If we have to rationalize a certain number, we need to multiply and divide with the conjugate of that number. Now you know what is conjugate mean. Let's see. Try to understand it by the example. 1 by 2 plus root 3. See, tell me whether this is irrational or rational. The whole number, rational or irrational? The whole number? Yeah, irrational. Numerator is rational, but denominator is irrational. So it is irrational number as a whole. Now, we have to rationalize, means the meaning of rationalization. We have to rationalize. See, there is no definition of conjugate. Conjugate is a term given. If the numbers are written in positive form, then their conjugate would be in negative form. Simple. When we replace the sign, those numbers are called conjugate of the previous. So this is a key word used in mathematics. So 1 by 2 plus root 3, we have to rationalize. Rationalize means we have to bring rational number at the denominator. Right now this is irrational and we want to bring a rational here. So the rule says if you want to bring a rational number, you need to rationalize, and to rationalize you need to multiply with the conjugate. Simple. So what is the conjugate of 2 plus root 3? It would be 2 minus root 3. So you need to multiply with 2 minus root 3. But since you are multiplying this term from your side, so to keep the value same, you need to divide also, because this is not in the question. If you are multiplying from your side, to keep the value same, you have to divide also. Now see what is going to happen. Multiply this with the numerator, it would be 2 minus root 3, and add the denominator, a plus b, a minus b, a square minus b square. 2 minus root 3, 4 minus 3, 2 minus root 3 by 1. Now see, here at the denominator, now we have a rational number, and this we wanted to change this irrational to rational, and we got it. So our purpose is solved. So again I'm coming. Rationalization is a process to bring rational numbers at the place of irrational numbers. Simple. That process is known as rationalization. And how the rationalization is done? Rationalization is done by multiplying by its conjugate. And since we are multiplying from our side, we need to divide also to keep the value same. So we can say by multiplying and dividing by its conjugate, we can rationalize a number. Okay. So one simple question, 1 by 5 minus root 7. Tell me, after rationalization, what would be its value? I'm waiting. Now I am waiting. Tell me the value of this after rationalization. 1 by 3. Why 1 by 3? I'm still waiting. By 18. Yeah, this is the correct answer. Correct. So To rationalize this one, we need to multiply with its conjugate. Its conjugate is 5 plus root 7. Then multiply and divide 5 plus root 7. Here we will get 5 plus root 7. At the bottom, we will get 5 square minus root 7 square. Then 5 plus root 7, then 25 minus 7. 5 plus root 7 by 18. So this is rationalized. See, at the denominator, we wanted to bring a rational number here. And now it is a rational number here. So our purpose is solved. So we are able to bring rational number at the place of irrational number. And this whole process is known as rationalization. And how we achieve this? By multiplying and dividing by conjugate of the number. Conjugate of this. Correct? Okay. Now the next question. 3 plus root 2. 3 plus 2 root 2 upon 3 minus 2 root 2. Rationalize this. Tell me the final answer. After rationalization, what you are getting. You have to focus at the denominator only. You need to multiply with the conjugate of the denominator. That's it. No matter what is there at the new. In rationalization, normally we bring rational numbers at the denominator. Okay, so I'm waiting. 17 plus 12 root 2 upon 1. Okay, good. This is the correct answer. So rationalize this. The conjugate of 3 minus 2 root 2 is 3 plus 2 root 2. Then divide also with 3 plus 2 root 2. Now see, add the numerator. You are getting the same number. If this is A, then this is also A. Now A and A, after multiplication, we will get A square. So we can write 3 plus 2 root 2 whole square upon here A minus B, A plus B, A square minus 2 root 2 square. Now we have to use A plus B whole square identity. We can write 3 square plus 2 root 2 square plus 2 into 3 into 2 root 2, 2ab form, A square plus B square plus 2ab upon A square 9 B square. 2 root 2 square means we have to write 2 root 2 into 2 root 2. This is the meaning of 2 root 2 square. Now 2 2 ja rational 4 root 2 into root 2 2. As I explained earlier, we have to keep in memory root a into root a is always a. So root 2 into root 2 is 2. 4 into 2 we will get 8. So here we are getting 8. Here 9, it is 8. Then 2 3 2 after multiplication 12 root 2 by 1 we will get 17 plus 12 root 2 by 1. So this is the answer. We are able to rationalize. Our purpose was to bring a rational number at the denominator because earlier it was irrational. So by multiplying its conjugate, we brought a rational number at the denominator. Now tell me whether rationalization is clear or is still any doubt. Okay, good. Good. Very good. Okay. So now I'm going to show you when more than two terms are Okay. Now I'm going to show how we can rationalize when denominator contains more than two terms. Right now, in all the examples which we just showed you, there were two terms, 2 plus root 3, 3 minus 2 root 2, like that. How can we rationalize a number when it contains more than two terms? For example, 1 by root 5 plus root 2 minus root 3. Okay, or just change like root 2 plus root 3 minus root 5. Okay, see how this question is different from the previous examples. In those examples only I had written two terms like this. Here the denominator contains three terms. So how can we rationalize this one? Not a big deal. We have to follow the same rule. See, just assume these two terms as A. That is the only thing you have to do. And then assume this is B. Means you have to think that it is of the form A minus B. That's it. Same rule. Now this number is of the form A minus B. So we need to multiply with its conjugate, and that would be A plus B. This is A minus B, and its conjugate would be A plus B. And these two numbers will together call A. So it will remain same. Root 2 plus root 3, no change here in the sign because it is A, our assumption. This sign will change to plus and then B. Since we are multiplying this number from our side, to keep the value same, we need to divide also. That's it. Got it? Now follow the same rule. When we will multiply root 2 plus root 3 plus root 5. Here, this is A, this is B. So in fact, this is A and this is B. So A minus B, A plus B. It would be A square minus B square. Root 2 plus root 3 whole square minus root 5 whole square. A square minus B square, using the identity. At the numerator, it will remain same. Now, here we have to use the identity A plus B whole square. It is A square plus B square plus 2AB, 2 root 2 root 3. And then its whole square is 5. Here I have used the identity A plus B whole square. A square plus B square plus 2AB. Simple. Now, root 2 plus root 3 plus root 5. Here we will get 2. Here we will get 3 because we know root A square is A, root B square is B. Now here it would be 2, root 2 into root 3 would be multiplied together. We will get root 6. Then minus 5. See, this plus 5, this minus 5 going to cancel each other. Now we have the value, root 2 plus root 3 plus root 5 plus 2 root 6. Now tell me whether our purpose is solved or still it is not solved. What was our purpose? The purpose of rationalization is to bring rational number at the place of irrational number. So here it was irrational. To bring rational here, we multiply with its conjugate. We are getting this. But what we are able to see that it again contains irrational number at the denominator. So our purpose is still not solved. It means we have to rationalize again. Still the purpose is unsolved. Since only root 6 is present here, no sign in between 2 and root 6. So it's very simple. Multiply with root 6 only in numerator as well as in denominator. Now multiply. Root 6 into root 2 would be root 12. Here it would be root 18. And here it would be root 30. Root 6 into root 6, we will get 6 into 2, we will get 12. Now see, we are able to bring rational number here. Now our purpose is solved. But here we need to simplify it. Root 12, 2 into 2 into 3, 12 means we can take out common 2, so it would be 2 root 3. Root 18, 3 into 3 into 2, we can write 3 root 2. So here it is 2 root 3, here it is 3 root 2. We won't get pair of any number here, so it will remain same, root 30 by 12. So this is rationalization. So I explained some of the basics and very few questions of Olympiad level. I think none, maybe one only. Many things we have to learn in the classes. So if you are willing to learn a lot of things in the classes of advanced level also, in 9 itself, we will learn something which are essential to learn for the Olympiad purpose. We will learn that in the 9 in the classes of class 10 and some topics of 11th also. So if you are ready for all the rigorous work, you all are most welcome. That's from my side right now. So over
Yeah.
to you, Arti ma'am.
Thank you, Tariq sir. Thank you for the great session. So students, how was the session? You can let me in the chat box. It was amazing. Okay, great, fantastic. Okay, we are seeing great objectives here. Very good. Okay, okay. So students, do anyone have any doubt or any question you can ask if you have? No? Okay, okay then. So students, in the chat box, I have shared one link. Okay, you can save this link somewhere. Okay, so this is the link from where you can register for the. Okay, so now Tariq sir will meet you in the live classes. The live classes will start from 25th March. Okay, students. Yeah. So Tariq, Aarti ma'am, thank you for today. Thank you, students. Thank you, everyone. Okay.
Yeah, thank you so much, everyone. Hope you enjoyed the class, and I really hope to see you all in the regular classes. And if you have any doubts, queries after this session, also what you can do is you can drop us a message on our WhatsApp number, which is 95607 or you can drop us an email at support@olympiadsuccess.com. We would be happy to help you. Okay, kids? So have a great evening. Bye-bye. Take care, everyone. Thank you, Tariq, sir.
Thank you. Thank you. Bye bye.
Bye everyone. Bye.
Rajan,
Okay.
can you send the
Yes.
links? Yeah,
Yes.
Anmol is asking for.
So I have shared the links again. You can copy. Okay, then everyone. Meet you in the live is now. Yeah. Bye.